While the flat parts of the movement are being finished, rotationally symmetrical components are created in the company's turning department. It is part of Glashütte Original's philosophy to make even the smallest of the company's own stems, pinions, pegs and screws. The manufactured parts are so tiny most of the time that they must be collected by a fine sieve. The smallest of the screws manufactured here has a head diameter of only 0.4 millimeters, a thread of 0.3 millimeters, and a slit of 0.1 millimeters. In the toothing department, the sometimes microscopically tiny individual parts are worked and perfected by hand. This is how spring barrels, pinions and toothed wheels are created. On the bearing pivots of the rotating movement parts, only minuscule tolerances are allowed. Therefore, the pivots must be fitted to the drillings in the jewels using a process called burnishing. This type of grinding sees that the pivots are turned between two hard metal discs. Thus, the surface of the pivot is condensed, made more resistant to wear and tear, and its tolerance is improved to a maximum of 0.003 of a millimeter. Naturally, intense examination follows on the profile projector. The celebrated quality of Glashütte Original's watches is no coincidence. The hardening department is where steel components get their resistance to wear and tear. The parts are first treated thermally and then cooled in an oil bath by shock. The tempering that follows in a vacuum oven sees that the parts do not become porous and retain their necessary springiness. Examining their degree of hardness is done with a diamond. These parts have passed the test and now proceed to the next station. The first little functional units are now created in the subgroup assembly. They will later be part of the entire manufacture caliber. Enormous experience and an absolute feel for the material is demanded here. Under the microscope, 18 tiny weighted screws with a thread of 0.35 millimeters are screwed into the balance wheel. The screwdriver used to do this is again a special tool from the company's own toolmaking department. After being riveted to the balance staff and having the plateau added, the balance must now be poised. In doing so, the underside of the balance wheel gets a little groove milled into it, the strength of which depends on the size of the imbalance. After that, the balance and balance spring must be classified according to their oscillation behavior so that they can be optimally paired. Only then is the balance spring added and sent to a thorough final inspection before going off to assembly. The riveting of the steel wheel stems and their pinions to their spur gears is what creates toothed wheels. The wheels are tested here for truth in the round. To do this, one needs a little puff of air, a practiced eye, and, above all, a steady hand. For automatic watches, completion of the ball bearings and assembly of the rotor also takes place in the subgroup assembly. First, 7 balls are positioned and the bearing added, and the ball bearing pressed into the rotor plate. Now the rotor plate is added to the 21-carat gold oscillating weight. The two-tone rotor embellishes the back of the movement and serves to automatically wind the mainspring. The union of aesthetic demands and an obligation to Glashütte's history is especially tangible in the polishing department. tourbillon cage, index and swan neck springs seen here are brought to a high polish using a traditional tin polishing process. This is done using a tin batten with diamond powder and evenly moving it across the surface. A process that can easily take up to half an hour for a swan neck spring. For other components, such as a filigreed tourbillon cage, this can even take up to several hours. When beveling edges, as here on a 3/4 plate, Glashütte Original's watchmakers use a traditional process. This makes it possible to file the edges to exactly 45 degrees in all positions, with the material becoming denser along its outer edges. The special tool used for this is once again an in-house design. The decorative blued screws hardly reveal the immense amount of effort they need. Innumerable gentle hand motions first bring the screws to a mirror polish, with every fine little scratch removed with a great deal of patience. Now comes the tempering. With increasing warmth, the screws successively take on various yellow, brown, red and violet hues until finally the typical deep blue Glashütte Original color is created at about 290 degrees Celsius. The heating simultaneously builds a protective oxide coating. Another characteristic type of embellishment is the setting of jewels in gold beds, the so-called gold chatons. The chaton, which has been individually fit to its drilling, is brought to a mirror polish using the tin polishing process. Using elder pith, grinding dust is removed and the chaton is additionally cleansed. The chatons must be completely flat in order to be on one level with the plate's surface. With a calm hand, exacting eye and a special screwdriver, the blued screws are now added. This is the characteristic Glashütte 3/4 plate with beveled edges, completely in the tradition of the old masters.